Well, good afternoon. It's a great pleasure to be here and introducing this wonderful new series, The Architecture of Place, collaboration between the ICAA, INTBAU, and the Princess Foundation. This series of talks is a collaboration between these three organizations and focuses on the built environment and its impact on the health of individuals, communities, and the planet. Established and emerging voices will speak on their work to create a better built future, something we can all look forward to. Today's talk is entitled The What and Why of Climate Responsive Design, with Andrew Coates, Fatou Dieye, Yasmeen Lari, and Deependra Prashad. Today's group will discuss design that works with rather than against its local climate is unquestionably the change of the future. For now, climate responsive design seems something of a novelty, practiced and championed by the few and not the many. If we are to deliver to 230 billion square meters in new construction, estimated to be needed between now and 2060, while also reducing the construction industry's significant contribution towards global carbon emissions, the way we design needs to change and change fast. Fortunately, traditional, vernacular, and indigenous design have many possible solutions ready to be adapted and implemented. Sharing examples and lessons from Gabon to India, Pakistan to Panama, today's speakers will suggest a way forward for both people and the planet. Our first speaker is Andrew Coates. British-born Andrew Coates is the owner and director of Cresolus, Panama. For almost 20 years, Cresolus has been designing, building, restoring, and advising on tropical buildings that are sustainable. Over the years and through the design, construction, and restoration of over 250 buildings, Cresolus has concluded that there is a set of basic tropical design rules that cannot be ignored. Since 2006, Fatou Dieye has worked as an urban design, architecture, and sustainability management professional in the US, Europe, and East Africa. She is a former member of the urban planning and urban design teams of the New York City Department of City Planning and the City of Kigali Office of Urban Planning and Construction, One-Stop Center. She currently serves as Skat Consultancy's country representative in Rwanda. Deependra Prashad is the principal architect at DPAP Architects and is the secretary of INTBAU India. His work focuses on participatory community-based planning for urban regeneration in derelict areas and resource-efficient architectural design. He teaches sustainable and energy-efficient architecture at the Indian School of Planning and Architecture in New Delhi and is the co-author and editor of the Blue Drop series for the UN Habitat on Rainwater Harvesting around the world, as well as an INTBAU India publication entitled New Architecture and Urbanism, Development of Indian Traditions. I present to you the speakers for the what and why of climate responsive design. Thank you.
Today, I'm going to be talking about some of my work. I'm a practicing architect in New Delhi. I teach in this area as well. So I'll start right away. So I'm going to be talking about the two ends of the spectrum when we're talking about sustainable design. One is the aspect of essential principles, then the aspect of technology and how these two work with each other. And we have to, of course, deal with both while we are working or trying to achieve sustainable design principles. Now, in the Indian context, well, it's a large context. Besides the huge population, we do have the fourth largest installed electrical capacity in the world, sitting at about 360 gigawatts. And this is slated to grow to about 900 gigawatts by 2032. So we'll ourselves in the country be a big source of global emissions. Indian projects for the past 15, 20 years are now looking at building with green principles. Of course, a lot of our traditional architecture can be seen in the same light, but in between, I think there was a change, and now we are in a way looking at green principles very, very seriously. And there are now, in fact, a large number of green ratings and others which are operational in India. And our green footprint, as I was saying the other day, has grown manifold and is probably approaching rainbow footprint with the world is probably right now of that of the US. So we're probably approaching the same, just like I think we're approaching the corona footprint of the US as well. A few things which I thought I'll bring to light. One thing was that when we talk about a pure efficiency-driven approach, I think that gets overtaken by the increasing demand. Sometimes you see buildings like these, which are purely glass buildings, building in tropical areas. So they are ovens rather than buildings. You look at usage of materials like fly ash as a waste from thermal power plants, and we use them to make bricks. It's an excellent idea, but the quality of a lot of those blocks is so bad that it becomes more of a liability. The technology which is available, now you have energy efficient lighting, LEDs, various kinds of air conditioning systems, wastewater treatment systems, solar. So it becomes like a race to basically install all of these. And it becomes like a technological race rather than looking at the essential principles. So in light of this point, I'd like to showcase 3 of our projects with, in a way, an increasing level of technological intervention. The first one is the school building, which we did. And this is not green rated as such, but it enjoys very low EPI. EPI, as we use the metric in India, is basically the energy performance index, which is the number of units that a building consumes per square meter per year. So this is 20, extremely low. And this building is, in a way, a mix of what we tried as architecture, a bit of craft, as you can see, and trying to work with essential principles. So here, if you look at this particular illustration, we're trying to work in a climate which gets very, very hot in summers, quite cold in winters as well, though it doesn't snow here, but quite cold and very dusty as well. So it's an introverted building. It is something which lives off its courtyards. As you can see, the courtyards in the center. It gets cool air from there. It gets natural light from there as well. We're trying to use a lot of local materials. Excellent clay bricks are available over there, and excellent workmen to shape them too, where we can see these arches and other measures to be able to reduce the amount of steel in the building. Also, we've built this on reclaimed wasteland, and it's powered by bagasse, which is sugar waste. It's a sugar industry. So it's powered by that as well. Looking into the building, if you see the picture at the bottom right, you see a window and you also see a ventilator above that. Now, a ventilator is basically an instrument which was always there, present in our traditional idiom. Whatever light you brought in, it actually spread better than the light which came in from the main lower window. The second was that whatever hot air collects inside that building or that room, because of people, because of equipment, other reasons, because of the incoming heat from the solar radiation, all of that is able to ventilate out from this ventilator at the top. So it's something which is useful, and we try to, in a way, replicate this. So this is something which is based on the traditional idiom completely. This is the second project. It's an office building, similar climate, very hot, does get a bit cold, not as cold as that. It's something which we call in India as a composite climate. In this particular building, which is again not very large, on the top left, you'll see that there is an aspect of zoning. So the air-conditioned areas, which are those in red, actually face what we call as the northern direction, so that the direct sun doesn't come on it and our air conditioning loads don't go up. On the southern side, where we can also enjoy good winter sun, is where the non-conditioned areas are. In the diagram below, you can see the section of the building where, through the usage of the central open space, the courtyard, and also the edges, one is trying to get good natural light, not just into the superstructure, but also into the basement, actually. And on the top right, you have a view of the courtyard, which is very well naturally lit. The level of technology is, in a way, now going up. We are trying to use special walling systems, which are based on an EPS core, as we can see in the bottom right picture, which is a thermocol core, where we shoot concrete from both sides and make it into a highly insulated building where the heat loads gets reduced by a third. Besides that, of course, you have your usual solar. We're using energy efficient lighting. So this is somewhere which is in between, middle in the technology spectrum. And this particular slide showcases a much larger project, which is for the Ministry of Environment and Forests in Delhi, where our energy performance index or consumption per square meter is 67. On the bottom right is a picture of the building. It's a large office building. Besides having insulation on the walls, recessed windows so that the direct radiation doesn't come in, it has a large solar bank on the top, which also acts as a shade. The automation is much, much more, and it's going up to a certain level. I think we've realized as an outcome of a number of these mechanisms is that though the high performance design approach could also be there having technology, but it shouldn't be technology driven. And we must prioritize what is really the passive. This really controls the cost of the technology intervention as well. So in this particular kind of row, basically, I'm trying to just put a priority where we say that the building orientation in terms of how it faces the sun, how much openings we have, how do you insulate it naturally? How do you manage the greenery in the surrounding levels? How do you manage the daylighting? These are much, much more important than what you see down below, which is your efficient AC systems, your efficient electrical systems, your sensors, your solars. So I think the priority should and must always return to what is passive, what are initial design priorities which an architect puts out. I'll try and put across this point in another fashion. In this particular case, if you're talking about these two buildings, so if you're looking at this as something which is, maybe a rural building with natural materials, not very high tech. If you look at the red line, basically, the red line actually showcases the operational energy of the building, which is gradually increasing as you go over 8 years, 9 years, 10 years. In blue is basically the embedded energy of the materials themselves. And as you could see, this is about 2,500 megajoules per meter square. And it broadly, because of some maintenance issues, it increases a bit over the years. This is a picture or an illustration drawn by Leon Crea. And here he talks about how cities have changed from being very, very horizontal to being very, very vertical and tight, configurations. This also increases the hard surfaces in the building, in the city. It reduces natural ventilation of a lot of lower built masses. It reduces the dissipation of pollutants, which is a big issue. Air quality has become a huge issue in cities like New Delhi or Karachi or in other places. And it's all exacerbating the overall heat island of the city. This change is here to stay. We can't say that we go back. So technology does have a role, but if we hold on to the basic principles, it helps improve not just the building design, but the overall urban design as well. Our firm's been working with the private sector and the public sector construction departments for publishing and training on these essential principles, where we always say, passive first and active mechanisms can be done later. Active mechanisms are those which need electricity, which need, other resources, and passive are the basic essential design principles. That was my point here. Thank you very much.
We'll move on to our second speaker now, Fatou Dieye. So Fatou, the screen share is yours.
Hello, everybody, and thank you again to INTBAU and Prince's Trust and ICAA for having me this evening here, afternoon where you are, to be able to speak. So I work for Skat Consulting, and we are a Swiss consulting firm that is actually responsible for the implementation of a project that is financed by the Swiss Agency for Development and Cooperation. And we implement this project in the Great Lakes, but not the American Great Lakes, the Africa Great Lakes. So that's Rwanda, Burundi, and Eastern Congo. And so what I wanted to talk about today was how to really address the challenges of providing climate responsive urban buildings in this region. And the thing you should know about this region is it used to be the fastest urbanizing region in the world. And if you look at the way that it's urbanizing, it's really actually very low scale. So if you take the 4 principal cities, Kigali, Bukavu, Goma, and Bujumbura, and look at the way that they're urbanizing, you can see it's about 20% formal buildings and then all the rest informal. And the way we actually cut these buildings is that the top of the picture represents about the 20% informal, and then everything else is informal construction. Informal construction is done with materials that are recycled. It's for this urban population, all these new urban dwellers that are coming to the city that are looking for jobs, have low purchasing power. So just to let you know, between now and 2050, there will be 20 million new inhabitants in these 4 cities. This year alone, there was a need for 110,000 new dwelling units. And each dwelling unit has an average household size of 5. So you can really see that the population is pressing and really needs urban building solutions that are safe. And to give you an idea, construction, yes, should be a very important part of driver of economic growth in these countries. But the GDP here is 20 billion. And to give you a comparison, New York State, for example, is 150 trillion. So really, we're dealing with a lot of people and very few means to be able to make it happen. So the idea is, what can we think about in terms of building solutions that can allow us to address this urbanization and really be able to cater responsibly, both economically and environmentally, to these growing populations? And so what happens is, the first thing that people think of is, when they think of urban buildings, well, they should be cement block. And we should build storied urban buildings, because this is also a place where land is extremely scarce. Rwanda is on the continent of Africa, it's actually the most land dense country on the continent. And so what happens is that there's a demand for imported materials. And 2 things happen because of this phenomenon of searching for these imported materials, is that there's a massive capital drain. There are very few lime reserves in Rwanda. So all of a sudden you're importing cement from Tanzania, from Kenya, from Uganda, and all that money is going to those countries, as well as all the jobs that could have been generated from the production of these building materials. So that's about 50,000 workers' incomes that are lost from import deficits. And then again, when you do look for local material solutions, there's an abundant amount of clay here. It's an excellent quality, but that clay is actually being used to fire traditional bricks. And the production of tree-fired bricks is actually responsible for massive deforestation in this area. And of course, when it's just heated with firewood, it's just essentially heating the sky, and you end up with a brick of poor quality that also is environmentally very unfriendly. So the project really then, which has an objective to reduce the urbanization's climate impact, also to tap its unused employment potential. So all the rural youth who now no longer have farmland and who are coming to the cities, how can you actually use them, and how can they invest in building a new housing stock? And the way that you can protect the environment and be able to create employment is actually to figure out a way to be able to deliver housing and other urban building solutions at mass scale. And so the way that our project functions actually is that we take the housing supply chain. So we look at all the different actors, and here on this diagram that you see on the left, there are about 32 different actors, from the people who make the bricks, to the contractor who will use them to build a building, to the buyer, to the tenant, to the banker, essentially all the different actors that are currently involved in housing supply. And so what we try and do is really fix the broken links between these different actors. And so we address different themes like building material production, trade and quality certification, concept design and engineering, housing finance, construction, and user finance. So all the places that you see small orange dots, those are the interventions that our project is focused on, to be able to build those links between the different actors in the value chain. And with the idea that once you fix this chain, you should be able to usher in and be able to support massive delivery of affordable building solutions. So if I take a few elements along the chain, the first one would be, how do you develop a housing system or a construction system that's actually affordable and based on local materials? And so what we did in 2017 was we built a first modular customizable building system. So even though I'm an architect, this is not architecture, this is a construction system. Using a cavity wall system that can actually be reinforced, so there is reinforcement in this cube, it's not just standing, and really started to look at, okay, the most expensive building materials here are the cement slab and the roofing materials. So if you actually build story buildings, it actually becomes cheaper. And so what we did was we pioneered this house and showed how it could be stacked and multiplied with different party walls into a row house system in order to be able to build very affordably in this context and be able to supply housing units easily with simple technologies. And if we want to break it down, what this actually means economically and environmentally, if you look at the upper left-hand side, this is the traditional building material, and you can see that most of it is going to concrete. Now, if you start to look at new optimized designs, so our brick housing unit, for example, we're able to get the price down per square meter, from $350 to $200 per square meter, which is extremely affordable. And once you start to look at the different walling types, and from cement block wall to traditional brick wall, which you saw, an industrial brick wall, and then a cavity wall, which is the one that I showed you, not only is the price per square meter able to go down, but also the energy consumption that it takes in order to produce the cement blocks or the fired bricks goes down. The fuel type, you go from fossil fuels to actual bio-waste. So we're talking about sawdust, we're talking about coffee husk or rice husk in order to fire these products. And the CO2 that's emitted, we're at a fraction of the CO2 cost and a fraction of the cement mortar. So really starting to think about how can we have a design that actually minimizes or maximizes the local materials to keep that money in the country, and then how can we have something that's also more climate responsive. And so that's at the scale of the house. And the great thing has been that it's been copied since 2017. We built that first house. It's been copied all over the region. So in our 3 countries and the Great Lakes, it's been copied over 2,000 times in the last 3 years. And if you see a map just of Rwanda, you even find it in villages. People are using the technique and coming to look for modern bricks, which of course triggers the investment into the modern brick production. So again, creating jobs, creating investment opportunity through the construction sector, which means that our other portion of the supply chain that we need to target ends up being the low carbon brick making facilities. And so we've pioneered a series of kilns that are environmentally friendly. Again, they only use bio-waste. There's no smoke that comes out of the chimney. These chimneys that you see here are 26 meters tall, which means they're very fun to install. And these are kilns that are continuous kilns, so they never stop. You have to feed them 24 hours a day, and they just keep going and going, and it's all natural draft. So over the region, we are promoting these different types of technologies that are more environmentally friendly. And so there are the versions that are, of course, industrial versions with big machines and the big chimneys. And you see they make a brick that has a more improved water absorption and also a compressive strength that's higher, which allows it to be structural, which allows you to get a storied building without concrete columns, which again become expensive. But we've also pioneered some more simple designs. And so what you see here is actually an extruder machine, which allows you to make a brick not using any kind of mechanized equipment. And so this manual production of bricks is something that small teams, we can actually rent the machines out to them, and they can take these machines and actually go on site and begin to produce bricks. And in order to facilitate, again, the delivery of housing, what we've done are things, what I'm showing here, which is what we call an in situ brick production, which means that the brick production actually comes to the site. And so you will have clay delivery directly on the site. You have a production and drying area, you have those manual machines, and then you build your septic tank. So a septic tank that would be used for a real estate project, you actually start using it as an underground kiln. So we call it the septic kiln. And then you use that kiln to be able to produce the bricks to build your building. And so buildings are on number 5. You can see a picture of the septic kiln all the way on the left hand of your screen, number 3. And then once you're done producing the bricks on site, you can actually convert this kiln into the septic tank for the project, which means that the producers, who are the young people to whom we're renting all these equipment, they can pack it up and then be able to transfer and go to another site. So in terms of creating jobs and business opportunities for them as well, it's not only the big investors who are coming and building large brick factories, it's also these small mobile units that can move about the region and sell their skills directly to a real estate investor. And so this project that you see here, that you see in sketch form, actually it's a real project, and you can see it here. And these are the types of solutions really marrying the technology with the building material product and with the different actors on the supply chain to be able to really facilitate production at mass scale. So these are just some of the things that we do, all based on the idea that having a basic building block, which in this case is a brick, that is more environmentally responsible and that creates many more jobs than the traditional way of producing bricks, is really the key to be able to have locally sourced, climate responsive production for urban buildings at mass scale. Thank you very much. And just, I guess, to maybe say over the region, if this industry transformation really goes through the full process, you should be able to generate all of the dwelling units that will need to be built by 2050, which is about 3 million, with just 50 million less trees than if you were to produce with traditional bricks. In terms of tons of CO2 that's reduced by 2050, it could be 30 million tons of CO2 that are reduced. Laborers, you could have 150,000 jobs all along the supply chain. You could have builders and ceramists. So it really is a way to think of construction of climate responsive housing as an economic engine to facilitate the transformation of these rapidly urbanizing cities. Thank you very much.
We will move on now to our third speaker, Andrew Coates.
Hello, everybody. So I'm here in Panama, in a place called Gamboa. And Gamboa is in the middle of Panama, literally halfway up the canal. It was established in the beginning of the 1900s when they built the canal. And it is a canal town, if you like. It is hot and humid. It's sort of between 26 and 30 degrees Celsius. We get between 1.5, 2 meters of rain every year, and it's about 80% humidity. So it's hot and wet. So in the 30s, the Americans, who had this canal zone, which was 6 kilometers each side of the canal that they created, and they desperately needed workers to come and work in the canal zone. But of course, there was no AC then, and it was fairly harsh to get people there, and nobody really wanted to come. So they decided to create a kind of utopia, which was this tropical town, and make the houses and accommodation and everything as comfortable as they possibly could. So what they did was, not only did they work on the houses, but they created all of these amenities within a 10-minute walk. So it was, it's kind of what we've been doing with the Prince's Foundation in Gabon, this walk area where you could live, work, play, shop, go to school, get educated, all within a 10-minute walk. And that literally was what was happening here. So here you can see Gamboa, the name of the town, on the side of the canal. You can see the work area over here and all the amenities surrounding it. So that was 90 years ago. This is what it looks like now. As a community, we have managed to preserve the historical nature of all our houses and actually managed to pass a law. Unlike a lot of the old canal zone in Panama, sadly, it gets what we call colomitis. You know, for some reason, people like to put Doric columns on houses. I don't know why that happens, but we've managed to keep our houses as they are. What happened was the Americans came up with 8 basic house types. And if we could refer back to Dan's lecture, this got all of the types of houses from the single family dwelling to the sort of what they call the bachelor's quarters with 12 units in it. And they had a principal architect who was called Meade Bolton. And he came from building railway buildings in Brazil. And after fighting in the First World War, he came to live in Panama, and he lived here from 1918 until the 1930s when he started to design the houses. And I think this was very, very important because he learned what it was like to live here all those years without putting pen to paper, as it were, to design the building. So his designs were very much a response to the climate. My family and actually office that you can see here is in this building, which was built 90 years ago. It's pretty much unchanged. So what I wanted to do was look at it 90 years later. And, you know, we are tropical architects and we also build houses. And we also have renovated several of these houses. So we've kind of become the doctors of these houses. So we've seen what's gone wrong with them, what's gone right with them, the good and the bad of them. And so I wanted to share that with you. And I wanted to sort of see that what we could take and use now in more contemporary architecture. So this is our house. This is Meade Bolton. You see he's signed the bottom of it. Very nice. Beautiful drawings. There's a whole set of these gorgeous drawings with lovely details. And often we still use some of these details. We put them straight into our drawings. But what they came up with is a set of basic tropical design rules that they stuck to and they used in all of their buildings. And I think that what I'm going to show you, I don't have time to show all of the rules, is a few of the ones that I think probably make the biggest difference to our comfort and our lives in our house. Right, so the first thing is the house, as you noticed, is up off the ground. And this area under the house is actually surprisingly important, practical, and kind of fun too. So obviously it looks after the building during a tropical storm, and if there's a flood, we don't have any problems at all. But also it means that the air flows under the building all the time, and so we don't get rotten wood under the building. The top part of the building is wood, the bottom part is concrete. It also means after 90 years, I can access all of those cast iron steel pipes and replace them easily rather than having to dig into the slab. And now, you know, during the last 9 months, this has been an outdoor work play area. And all of these houses have this social area where people can be outside, but not in the rain. And that is surprisingly important. So we've used these rules. This is a building for the national parks in Gabon in Central Africa. They've got the same climate as Gamboa in Panama, hot and humid. And we basically have used the same rules, and the underside of the house, as the buildings, uses that same principle about getting it all off the ground. And of course, you know, it is muddy. Everybody's muddy, and this is a muddy area, which is good because it means it doesn't come into the house. The bottom structures don't actually touch the top structures, and that's for termites, so that there is this gap. But so far we built 16 variations of this building, and everybody is very happy with them. The second rule, if you like, that I want to talk about is the walls. Now, what's interesting about the walls here is that they are single-skinned. There's the structure. This is what we call the library. And you can see it's only got one layer of wood. And so often I hear people talking about insulation. And if you don't let the walls heat up, the best thing to do is to have a light wall that doesn't retain the heat. And that's it. If I close this in, I'm sure that, and I have got bits of the wall that have been closed in over the time, but when I pull off the inside, all the creatures and animals and bugs and everything and humidity and mold get stuck in there. So in actual fact, it is great just to have a single skin wall. On the right-hand side, you'll see a hotel that we built, a single screen wall. Everybody was very nervous. It's going to be too hot. It's not insulated. It's absolutely fine. You know, the outside temperature is not terribly, terribly hot, as long as the sun doesn't hit it. Rule number 3, I think I'm up to. Everybody knows this, and we already talked about it today. We know that hot air rises, and I don't know why we kind of seem to always forget that you've got to get it out. And so internally, this has these devices, which is about as simple as you can possibly come up with. And after 90 years, I can tell you it's still working, and I'm sure it'll still be working in another 90 years. Very simple device. It lets the hot air out of the room. It's easy to do. If we can think of our rooms as a series of connected ducts to let the hot air out, that's what it is. And then it can go out here. I have actually painted these eaves since I took this photograph. I didn't realize they were quite so filthy. This had somebody put glass in the window. We have since taken all the glass out. You don't actually need any glass. This is just screens for bugs. So you can see the hot air comes out here and out there. Also, this bounces the light back into the room. So it's very nice, very comfortable. We never feel like we need AC, even though this is a hot, humid climate. Here's a couple of buildings that we've done, completely different. Everybody was a bit horrified. This is a bare zinc roof, but it doesn't get hot in there because the air flows over the top part of the house, same thing. This is old louvers doors. We've used that to ventilate through the roof. This is another house that we've done. The good thing about these louvered doors is that they're actually very difficult for people to break through. This picture on the left, this room became actually too windy, too much airflow going on inside it. You can see it goes right up through. We used our doors again on the top there. And the client asked us to put perspex over some of the louvers because there was just too much air going on, which is a good thing because it's easy to put louvers. It's very difficult to crack open a window. So the next rule is, and I'm racing a bit, I'm sorry, I've got so much to tell you, is these big eaves. Now, this is something that is a kind of ubiquitous tropical design, but it just totally makes sense. This is the old schoolhouse in Gamboa. It's not my house. It's still there. It's still in use. But you can see how this functions. It's just obvious. It works well. So 1.8 meter overhang, that is the standard. And the reason for that is because when it rains, and we have a rule in our office that says you have to be able to open all windows in 45-degree rain, otherwise the window can't go there. And that means that when there is a big tropical storm, you can open the windows and you get the nice noise of the rain. And of course, you get the cool, refreshing air, which is a tremendous relief. I mean, you can't have windows that you can't open. It seems to be a fairly easy rule, but you'll be surprised how many people want to cut the eaves off and then they get wet inside the house. So this is our house during a good storm, and we feel perfectly comfortable when there's a good storm. Now, I actually think there's a good test for a good tropical house. So if you put on a pair of shorts and a t-shirt and wait until there's a great big storm and then turn the power off and live in it for 48 hours, you should still be comfortable, because this is not New York. It doesn't freeze you to death. You should be able to survive comfortably in a tropical house without any electricity at all. That's the test. Certainly, we've experienced that in our house many times. We do have power cuts, and it's fine. We're perfectly comfortable. So here are my tropical responsive design guidelines. There's 20 of them. I'm not going to go through them all now because we don't have time, unfortunately. I'm sure that you could get this sent to you if you would like to. But you can see fairly quickly what I've just been talking about with a few more extra ones. This is the National Parks building in Gabon that we've been working with them. And in the top right corner up here, this is something we worked with Opticos and the Princess Foundation. These were houses following those same design guidelines. It's interesting, people actually respond well to tropical houses. I know it's a little cliched, but people like tropical houses. They look good. This is a tropical house in Panama that we've done. The client actually asked us to put AC and glass in the bedrooms, which are the top here. And he's told us 4 years later that he has never turned on the AC because he's perfectly comfortable. But quite often we found that the clients are too afraid not to have AC because they might be uncomfortable. So we do what's called a hybrid house, which works completely well with AC or without AC. And of course, the benefit of that is you're making a highly efficient building, because if it's comfortable without AC, then you don't need much AC to cool it down, as opposed to some of those towers that we were looking at earlier that were the ovens, literally. Anyhow, so there's one. Well, the trouble with the tropical buildings, they have this kind of badge of colonialism, which people, I think, are frightened of building a house that looks colonial, especially in an old colony. But having spent 20 years traveling around Africa and Central America, and what I've been doing is collecting vernacular architecture, which wasn't the colonial architecture, it was the vernacular local architecture. And in fact, it's the other way around. What happened was those colonial people came from Bedford in England. They didn't know anything about tropical houses. What they did was they copied what the locals were doing and turned it into what we now see as colonial architecture. But as in actual fact, it originates from the vernacular of those countries. So we shouldn't be too afraid of it. But at the same time, you can also do stuff like this, which is, you know, a contemporary interpretation. The rules are still all there, all the rules that I've been talking about, but just in a more contemporary way. And here's one where we managed to combine both of them together. And that building was actually so cold, it feels like the AC's on when it's not on.
Before we move into Q&A from participants, I'm going to just do a very quick overview of Yasmeen Lari's work, which she would have presented herself had she been able to join us today, with the one benefit of my doing it instead of Yasmeen, that I'll be less modest than she would have been had she been doing it herself. So Yasmeen Lari, who is chair of INTBAU Pakistan and also founder of the Heritage Foundation of Pakistan, pictured here at an INTBAU conference in Karachi last November. So just very briefly to say that Yasmeen was Pakistan's first female architect. She's had a very prominent career in design. This is the Pakistan State Oil Company headquarters in Karachi on the left, designed by her. When she retired from architecture practice 20 years ago, she, in fact, increased her workload enormously, but switched to working entirely towards zero carbon design and to working for a very, very different type of client. So she went primarily to Sindh, where Karachi is based in southern Pakistan, and to Makli, an area about 80 kilometers to the east of Karachi, to work specifically with communities in that area. And what you can see on the right here is from the inside of a community centre, the Zero Carbon Community Centre on site at Makli. So to show what Yasmeen has managed to accomplish is that she, as one individual, has been able to sort of unlock the potential, for want of a better expression, of many thousands of community members in the Makli area, and has come up with ways of introducing sustainable sources of livelihood alongside the basic necessities of life. So secure shelter, the ability to cook, the ability to have access to eco-toilets, the ability to have hand water pumps for water. And what this slide shows is just the 8 different villages that are in the region that can function sort of in symbiosis with one another, so that people have what is required to live a healthy and a dignified life, but also with elements of really good design thrown in. And that's been one of Yasmeen's predominant philosophies, is that good design is absolutely for everyone. And the other 4 villages here, as you can see, it covers everything from cashew making, so traditional ceramics, and that's tiles, it's hand basins, as well as on the previous slide, there were briquettes being able to use to fire outdoor stoves. There's agriculture, there's a production of dairy products, also some hosting. Makli has a very old necropolis on site as well, so being able to cater to tourists there, and some residential accommodation that's been built. This just to show more in detail the chula, a traditional Pakistani stove, which Yasmeen's adapted a design that makes it very easy to build by community members. And this has introduced far cleaner, safer ways of cooking and preparing food, which then the women who are doing predominantly the cooking are able to decorate themselves. And you can see, especially on the right, the really just beautiful effect that that has. This is an animation that I'll just show that sort of covers that Larry octagreen structure that was one developed with prefabricated bamboo panels. You can see coming together there, and those going into an octagonal shape. Very quick and easy to do, bamboo being sourced and grown locally. There's then a reed thatching, and it's rendered inside and out, and a thatch roof that goes on top. And that shape and design, this is a region that's affected by earthquakes, but also by floods each year. And these designs are shown to be extremely resilient to earthquakes, and also just by building up the earth rendering on the outside, actually making it far more impervious to flood as well. And this continuing to show just how that's similar, the same materials, similar shapes, just being put together differently, able to be adapted to create different types of space. And this here finally is showing the design for the INTBAU Centre, which we built last November with support from His Royal Highness the Prince of Wales, in fact, which was inaugurated alongside the INTBAU conference last November. So then just to show a section of the completed INTBAU Centre, which is on site now, and once things are back to normal, that plus the residential accommodation alongside, and the Zero Carbon Cultural Centre, which you can see to the left in this image, will be up and running again for more hands-on workshops and training in these building techniques. So I hope that some of you on the call today will be able to join us for one of those in a future year. And just actually finally to come on to, I meant to show this at the very end, but I will just allude now to the fact that INTBAU in 2021 is planning what we're calling the New Growth Architecture Challenge. So that's going to be looking for housing solutions from around the world that are very inexpensive and easy to build, and that update the vernacular, so to speak, locally. So what Andrew was just mentioning, finding those extremely smart but straightforward local ways of building and adapting them where necessary for 21st century needs. So a very quick overview of Yasmeen's really quite exceptional work and the exceptional people that she works with. So we can now move on to Q&A. So let's maybe start. Fatou, there's one here I can see for you from Daniel, and he's asking about unfired earth blocks and rammed earth, which can optionally be stabilized with lime in wet conditions, can mean a further reduction of embodied energy. So had that alternative of unfired earth block and stabilized potentially with lime, had those been considered for your ProEco project, and any pros and cons that you could elaborate on in the context of your Great Lakes region sites?
So yes, actually, this project is done in phases. And during the first phase, the team, even before I joined the project, built a series of homes with hydroform blocks, which are compressed stabilized earth blocks. You do need to put a little bit of cement in there. And so it means that your soil has to be, you need to have proper soil and then be able to do the proper mix. So it's actually quite labor intensive. You need to know what it is that you're doing. And it doesn't necessarily create as many jobs as the fired brick product does. And so when we look at the map of this region, you know, there are these hotspots, these cities that are growing. And then of course there are peri-urban and rural areas. And so I think really what it's about is finding the solutions for the right area. So for an urban building, I would not, and this is a seismic zone, by the way, with the mountains and the gorillas and everything. So you need an urban building solution that can resist for earthquakes and that can allow you to do storied buildings. Kigali, if you know, it's the land of 1,000 hills. So it's a terrain that actually 50% of the city is not buildable. So going up really is one of the only solutions. So that I would say is an urban building solution, but then for rural and peri-urban and village solutions, there really should be a lot of these mud, brick and block and wattle and daub mixtures to be able to make these buildings. And there are quite a few.
I wonder, one that I might actually put to you, Andrew. So having you described the project that was in Gabon and then also the work obviously that you've done in Panama and throughout Central America, how much sort of learning from each place, I mean, very different geographical parts of the world, but where the climate is similar, do you find that then the techniques, the materials are pretty transposable one place to the other, or did you learn quite different lessons in different places?
Yes. I think what's fascinating is that if you look at the vernacular architecture, there are certain things that are repeated. It is just purely a practical response to the climate. And people come up with the same solution again and again. I mean, the big roof, keeping the building off the ground in somewhere that is wet and humid and has a lot of rain, you see that repeated. I mean, I have guys who work for me who are Wenan Indians, and I look at their houses and they're kind of a stick version of my house. And then I go to Gabon and I see a similar house there as well. So living in those environments, come up with practical solutions. I don't know why when we start to look at more contemporary architecture, we forget that somebody's already done that. Why are we trying to do something? Somebody's got a solution for it already. Doesn't mean to say we have to directly use it, but you know, they've solved a problem.
Switching climates completely, because the three of you were mainly talking about places that are warm. We've got a question from Preston, who's wondering about climate solutions for cold weather, thinking specifically about maritime Canada. So any of the three of you, have you had experience? I know Deependra, you certainly mentioned where the Sri Ram Junior High School was built. You have both cooler and warmer temperatures, but any cold weather ideas that any of the three of you have come across in your experience?
So we have built in the cold as well. And I think the good part is that when we're talking about really hot climates or really cold climates, some of the principles again remain the same. If you keep it compact, if you keep it tight, if you keep it well insulated. So either you retain the heat or you retain the coolant. So basically it works. And if you're having a situation like Andrew's in, then you want to keep it more open and, you know, more ventilated. You know, certain commonality in principle, which also works in a weather like the composite climate, where it's very, very hot and very, very cold. So it's working, and actually the compactness is really working in both seasons. Yeah.
Andrew or Fatou, anything to add to that one?
I mean, it's the opposite to what we're trying to do. If you can retain heat, that's a good thing. For us, we don't want to retain heat, but it is interesting, you know, thermal qualities of materials. Just one thing, for example, the roof on these houses is made out of copper. The thing about copper, like a copper pan, you turn off the heat goes straight away. So if you think of the very basic materials, the sort of core, like a brick or something like that, then that's a good place to start, I think, is the core materials.
And of course, for us, brick in especially the cavity wall has great thermal mass properties. It actually can hold the heat during the day and then release the heat at night when the temperature goes down. So brick is really something that's adaptable and people feel quite comfortable. And here it's just a preference. Everybody aspires to have, you think of safety as well as thermal comfort.
Good, thank you. Well, I'm speaking from a London that is freezing, absolutely freezing today. And also as a Canadian from the Maritimes originally, and I've never been so cold as I have been since moving to the UK, because here it's damp and cold and there isn't much double glazing. So it's one thing that can also help. A good question from Veronica, who's mentioning the Sustainable Development Goals, the SDGs, and pointing out that, of course, vernacular architecture has a lot to contribute and teach, and does quite a lot very naturally to move us all towards achieving those Sustainable Development Goals. And she's asking, do the three of you think that the SDGs and its targets, are they a good tool for measuring the contributions that vernacular architecture can make?
So SDG 11 for us, sustainable cities is something that we're quite passionate about, is to figure out, again, and that's why I was talking about building the systems that can allow mass delivery of these houses, to actually really be able to rethink the cities. Climate change here in Rwanda, I've been here for 7 years, and the weather patterns have changed drastically, which means that there's a lot of flash flooding now. And so if you can imagine, if you're in a crowded settlement, in a house, the walls might not be very resilient to the rain, you have wall collapses and landslides, there can really be a lot of damage. So thinking about building and how it contributes to making safer, more affordable cities is really the SDG that we're focused on. And then you back into all the environmental and building and vernacular architecture discussions to be able to answer that, what we think is a larger question that has incredible economic impact also for these cities.
To make cities more sustainable, I think we're often building behind the curve in terms of climate. There tends to be, we'll stick an AC unit in it and that will cope with the climate, and that goes against all of the SDG goals. The comfort of people can't afford that. And what I've continued to be surprised about is seeing houses in places where there are not enough of electricity that are so uncomfortable as soon as you turn off the AC. We can expect the AC not to be working quite frequently and more. If we look at it from the other direction, we say, if we design this to work without the AC first, it's going to use less energy and be more sustainable. And that, I think, goes into those goals.
The primary goals in terms of what we are all talking about, I think energy or electricity is something which we are in a way more comfortable about, even in India now and in many other countries as well. I think it's the issue of water and air, which has become in a way a predominant problem, especially here in India. Northern India right now faces huge pollution issues because of various reasons. So I think it's in the water, it's in controlling the water supply and the water quality and the air quality that the real challenges, to the SDGs are there. And we can provide so much, within, we can provide livelihoods and so on. But if these aspects are not taken care of at the city level, certainly buildings do have an effect in them. A lot of our buildings, their footprint is maybe half of what a usual building would be. But in the overall sense of the word, in terms of what the city is doing, it's a drop in the ocean. So I think that's where this whole movement grinds to a halt, and we need to do so much more, air quality and water quality.
Thank you, Deependra, very much. One directly to you, in fact, Andrew, which is the difference between the single skin wall and the hybrid approach that you mentioned.
We assume that because a building is air conditioned that we should insulate the walls. But if you think about, if I'm looking, I actually have an AC in the office because the computers, we turn it on for a couple of hours in the afternoon and it is at 76, sorry, for some reason it's not the American system. And the outside temperature is only a couple of degrees different from the AC temperature. And so the single skin still works. As long as it's well sealed, you don't need super insulation, because the difference, really the AC is dealing with the humidity. It's not dealing with the temperature. The temperature is just a few degrees, a tiny amount. The work it's doing is sucking the humidity out. So my computers last a few more years than they have been before I put it in. And so we don't insulate even with AC, as long as the sun doesn't heat up the building. And that goes against a lot of people will tell you we don't agree, but I've tested it now extensively, 250 buildings, and that's fine.
I think everyone on this session trusts you So we'll take your word for it on that. One last question, which picks up on a couple that were coming in from the audience anyway, to put to each of you in turn. For architects out there, possibly who are just at the beginning of their careers or maybe still in study, how can they get into working in climate responsive design? As we said at the beginning of this session, it's not yet the mainstream norm that it perhaps needs to be.
I think one of the issues is that there are now a number of masters or specialization courses which are coming all over. And I feel that that shouldn't be so. Maybe we should look at basic undergraduate architects and focus on those. If you can make a dent there, then you've had it. So I think in all their experiments, I think once they get into architecture, if they're trying to integrate this issue everywhere, and ultimately it's habitat. So, I mean, it's there's no taking away from the climate. So if they're doing that, then that's good.
Great, thank you. Fatou, would you like to pick up next?
In certain of these regions, I mean, we started looking at climate responsive in an area where there is deforestation problems since the 1960s in this region is really marked. If you start to look at maps and you can see that something really needs to be done, not only from the point of view of livelihood, because they're just decimating entire forests, but also then in terms of figuring out a smart way to build. And so for me, it would be actually finding an area where there's an intersection of problems and really starting to apply systems thinking. And if you use this kind of systems thinking, you all of a sudden have to think about the environment and the economy and how these things go together. And you naturally start developing and designing solutions that, if they're going to work and if they're going to be adopted, have to be so locally anchored that there's really no choice. So if I were to do this again and try and find my place in the world, I would really look at where there is an intersection of these challenges, and then you'll find yourself right at the heart of where the discussion is and right where the design problem actually begins.
Good answer. Thank you. Andrew.
I mean, I think by nature, architecture is a practical discipline. And what I found is a lot of people come to me or I interview with no practical experience at all. And I think if you want to practice architecture, you should start on a construction site in somewhere where it's not a first world, where everything is there and available and easy to do. It's somewhere where things are a little bit more difficult and go wrong continually. And you have to use practical solutions. When you do a design, it has to be something that people can build in the field, when it's raining and the truck's broken down and all of that stuff. And if you've come up with a very fancy design, which is quite frankly impractical, you failed to do what the ultimate goal is, which is to build a good building.
Good advice from all three of you. Well, so it just remains for me now to thank the three of you very, very much again for speaking and for your responses in this Q&A. And I'm going to hand over to Edith Platten, Director of Education at the ICAA, just to wrap things up.
Thank you so much, Harriet. And to Andrew, Deependra, Fatou, and Harriet, of course, for standing in for Yasmeen. And your first class moderation, as always, is a fantastic discussion. So thank you all for joining us.